Hello everyone, welcome back to another Aredzepi math video. It's been a while, but I'm excited to be back. I hope you guys are excited to be back too. So we're just doing a little review on partial fraction. I'm about 90% sure I did a video on this, but I didn't know what I was doing back then. But we're just going to use this to build on in future videos, right? We're going to talk about how to take integrals using partial fractions, and of course we'll need to do that. So the reason you would do partial fractions is you want to simplify a rational expression, right? When doing partial fractions, like you'll see in a little bit, is we break the fraction up into two parts that, when added together, equal the original function, right? So let's look at this function here. We got 1 over x squared plus 5x plus 4, right? Very simple. We see the denominator here can be factored. That's a telltale sign that you need to do partial fractions. The denominator that can be factored, all right? So let's do that. Let's factor this denominator. You guys should do this in your head. It should be easy. 1 over x plus 4 times x plus 1. All right. Now, like I said earlier, we want to create this function to another function that, when added together, equals this, right? So what we're going to do is we're going to try to split this up, all right? So we're going to use some random constant a. Now, as you'll see, a and b, eventually, are just placeholders. They're just placeholders for some random just number, right? Could be any number. We'll find out. All right, so a times x plus 4, or a divided by x plus 4, plus b divided by x plus 1. And now this can equal to this original function, right? That's why we want to do that. We're pretty much solving for a and b here, all right? 1 over x plus 4 times x plus 1. All right. Now, I left it like this because what we're going to have to do now is we're going to have to multiply each side by x plus 4 and x plus 1, right? And it's just going to be a lot easier. So we're going to multiply both sides by x plus 4 and x plus 1. Okay, so when we multiply it for a, the x plus 4 is cancelled out, which will leave us a times x plus 1 plus, now the b here, the x plus 1s will cancel out, and it'll give us with a nice b times x plus 4 is equal to 1, right? Now, this is going along really nicely. So why we multiply this, if you're kind of glossed, is we want common denominators so we can actually add the two separate parts, right? So with a fraction, you need common denominators, right? So now, a times x plus 1 plus b times x plus 4. So I just learned this trick maybe a week ago. Usually you do systems equations here, but my calc teacher, I didn't know this until a week ago. You can just plug in the numbers here. So for example, whatever equals 0 into this expression. So let's plug in our two numbers that will equal 0 are -1 and -4. So let's plug them in, right? Let's do x equals -1. So the a will cancel out. It will give us b. It'll give us 3b is equal to 1. All right, because -1 plus 4 is 3, and then now we just divide b by 3, which is equal to 1/3. All right, we just solve for b. Pretty cool. Now we're going to do the same thing for a. We're just going to plug in now -4, right? So -4 plus 1 is -3, so we get -3a is equal to 1, and we'll get a is equal to -1/3. All right. So we found out a and b. Now we're just going to put it into our rational function now. So we'll get, we'll put a little equal sign because this is what it represents. So we'll get -1/3 over x plus 4 plus 1/3 over x plus 1, right? And there you go. That's how you do partial fraction decomposition. So if we were to add these, right, so multiply by x plus 4 and x plus 1, it will eventually turn out into this original function, right? And we'll see the uses of this. This is a much easier function to integrate than this, and I mean, that's the whole point of it. So I hope you guys enjoyed. Like, follow, subscribe, share it, put it on your Facebook or whatever. Have a great day.